In this projectile problem, we have this guy right here who's throwing a ball with some initial velocity at an angle of 40 degrees. And his goal is to figure out what initial velocity he needs to make the ball hit point A or hit point B or anywhere in between. So we want to find a range of initial velocities that will allow him to do this. And what we need to do first is, well, we have to figure out how far away A is and how far away B is from his position, from this position right here, which is what we're going to call the origin, and we're going to call this position 0, 0. So position A is going to be, if we look at this, A is really in the x direction. It's this 8 meters right here plus whatever this distance is. And this distance is going to be, this is same as this distance. And this x right here, we'll call it x1, is the same as this x1. And x1 is going to be equal to this 10 meters times the cosine of 35. So this total x, we'll call it x final. This total x final, we'll call it x final A, is equal to this entire distance. So it's equal to 8 plus this 10 cosine of 35. And this simplifies out to be 16.19 meters. And likewise, we need to do the same thing with the y direction. So how far up is point A from the ground? Well, point A is this 2.5 meters right here, plus this distance right here. And this distance is going to be 10 times the sine of 35. So the entire distance, so our y final A is going to be equal to this initial 2.5 plus this 10 times the sine of 35. And this is equal to 7.23 meters. And that's just the location of this point A with respect to this origin point right here. It's right around where the ball is thrown. And with this projectile problem, we don't care that the projectile is landing on this slanted wall. We just care about the absolute position that it's going to hit the wall at. So what can we do now? Well, we can look at point A, and we can look at the horizontal, and we can look at our vertical components. And with horizontal, the only equation we have is a final x position is equal to an initial x position plus a velocity in the x direction times time. And we have this x final position. We just found it. It's 16 point. Let's keep our colors straight. So this is 16.19 is equal to an initial x position, which is going to be 0, plus our v naught x. And what is our v naught x? Well, we don't know what our v naught is, but we do know that this is v naught, and v naught x is going to be right here, and v naught x is going to be equal to v naught times the cosine of this angle, and this angle is 40. So it's v naught times the cosine of 40. And our v naught y is coming up here. So our v naught y is going to be equal to v naught times the sine of 40. And we'll need that later. But so our v naught x is equal to v naught times cosine of 40 we can substitute that into this equation. And it's multiplied by some t value, and this t value is unknown. However, we can solve for v naught t, and we get v naught t is equal to this 16.19 divided by the cosine of 40. And we're going to use this later. And we're actually going to use it when we use our vertical equations. So likewise, like we have a final x position here, we have a final vertical position here that we just found, and this final vertical position is equal to final vertical position is equal to an initial position plus velocity of the y times a time plus 1/2 times the acceleration times time squared. Well, what do we have here? Well, we have v naught, which we can substitute in, and we're going to have a time, which we can substitute in. So if we start to substitute in our known values, we have a final y position. Our final y position is up here, and it's 7.23. So we have 7.23 is equal to an initial y position. Well, our initial y position is the 2 meters that it starts with, so it's equal to this 2 meters here, plus this initial y velocity. Well, we said our initial y velocity was v naught sine of 40, so we can substitute in that expression v naught sine of 40 times t plus 1/2 acceleration. Well, we have an acceleration coming down, that's gravity. And we know gravity in SI units is minus 9.81 meters per second squared. And again, we're going to have some t value, and this t is going to be t squared. And let's make this t right here the same color. So what do we do now? Well, we have this expression right here that v naught times t is equal to this expression. So if we can substitute this v naught t in right here, and we get, if we move this 2 over to the other side, we're going to get a 5.23 is equal to this v naught times t. So we're going to have 16.19 divided by the cosine of 40, and we still have a sine of 40 plus 1/2 times negative 9.81 t squared. And well, we can simplify this up a little bit. We get this 5.23 is equal to 16.19, and this becomes a tangent of 40 plus 1/2 times negative 9.81 t squared. And if we solve this equation, we're going to get a time, and this time, this t right here, time is going to be equal to 1.305 seconds. And so this is what we are looking for. Now, the other route you'd get is a negative 1.305 seconds, but because we're interested in this specific application of how long it takes, negative value doesn't really do us any good, so we're just going to take our positive route. Now, we aren't done yet. We're trying to find this velocity. So we have this equation right here, and we can plug we can plug this time in for velocity, and we can get that the initial velocity, the v naught, is equal to 16.19 divided by the cosine of 40, and this is times this time, which is 1.305. And if we do that, we get an initial velocity of 16.2 meters per second. So in order to reach point A, we have to throw it at least 16.2 meters per second. Now, we have to do this entire procedure again for part B, and let's do it. So, how far away from B? How far away is B from our initial point? Well, B is going to be this 8 meters plus from here to here, and this distance right here is going to be 17 times the cosine of 35, because it's this 10 meters plus this 7 meters. So that's how we get this 17. So this x final for B is going to be 8 meters plus 17 cosine of 35, and this is equal to 21.92 meters. And likewise for the y, we're going to have this initial 2.5 right here. So this right here is going to be 2.5, and how high is this right here? Well, this is going to be 17 times the sine of 35, and our y final at B is going to be this 2.5 plus 17 times the sine of 35, and this is equal to 11.25 meters. So what does this mean? This means that at 21 meters to the right and 11.25 meters up is this location of B that we're trying to hit. So we're going to do the exact same thing. We're going to have this horizontal position, horizontal. Hopefully I can fit everything I need to. So horizontal is a final x position, so 21.92 is equal to its initial velocity, so this v naught cos of 40, and times some time, and this time right here is t. So we have v naught t is going to be equal to 21.92 times, or divided by the cosine of 40. So this is our equation for our velocity here. Now we can look at our vertical equations, and we're going to use this y equation again. So we have 11.25, which is our final y position, is equal to an initial y position of this 2 right here, plus v naught in the y direction, times a time, plus 1/2 times the acceleration, and our acceleration is minus 9.81, and multiplied by a time squared. And substituting in our different variables, such as our v naught time and v naught y, we get this 9.25 is equal to v naught y is going to be v naught sine of 40, so v naught sine of 40 t plus 1/2 times minus 9.81 times a t squared. And v naught times t for us now is going to be this right here, and this is going to be 9.25. 9.25 is equal to this equation right here. So this V naught and T are going to get substituted for. So we have 21.92 over cosine of 40 times the sine of 40 plus 1/2 times 9.81 t squared. We're going to be solving for t squared. So again, if we just clean this up a little bit, we get 9.25 is equal to 21.92 times the tangent of 40 plus 1/2 times 9.81 t squared. I sort of gave up with the colors, and when we solve this, we're going to get a time is equal to 1.36 seconds. So in order to throw it from this point to point B, it's going to have to be in the air for 1.36 seconds. If we substitute this 1.36 seconds into this equation, we are going to get a V naught equals 21.92 divided by cosine of 40 times 1.36, and our V naught is going to be equal to 21.04. So this is 21.04 meters per second. So to summarize all this answers, that in order to throw a ball and reach between this point A right here and this point B right here, our V naught, let's pick a color. I haven't really used a lot of this. Our V naught has to be less than 21.03 meters per second and has to be greater than 16 meters per second. And you might argue it could be greater than or equal to if you're trying to hit point A or hit point B, but this is the answer for this problem.